Okay, so now that we have imported the data from the website and we have all of that here, one thing that I forgot to do was to make sure that the units were right. So this is kilopascals, but the Antoine equation uses just pascals. So we're gonna wanna change that. So T equals data, here, capital T, equals data, and we're gonna want, the index starts at 0, so we're gonna want that, and then everything in there. And then we're gonna call it log of P, because that's what the Antoine equation uses. It uses the log of the pressure. And we're gonna have that equal to NP dot log base 10 of, so kilopascal is 1000 times our data, and we want the second, and we want everything in there. So now that we have that, shift enter, run that, make sure that's good. And then so to model it, we're gonna need to add some more imports up here. So we're gonna want to do from plotly dot sub plots, and we're gonna import make underscore subplots. So we're gonna have that now, and then we're gonna do this little thing that, like, you don't have to do, but we're gonna do because I have this dark background and I want it to look nice. So we're gonna do import plotly.io as PIO. We're gonna do PIO dot templates. We're gonna do dot default equals, in quotes, plotly dark. So that's just gonna make sure that it has a dark background. So, oop, little error. Okay. Oh, I think I need an underscore there. Let's try that. Hello? Okay. So shift enter, that's good. Okay. So now that we have most of that imported, we're also gonna import another thing. So import JAX. So JAX helps us make sure that there's no rounding errors, because computers automatically have a certain amount of numbers that it'll round to, but JAX will make sure that it doesn't round weird and like mess up our results. So import JAX, and then we're also gonna do import JAX.numpy as JNP. So we're gonna do shift enter, that's all good. And actually, speaking of that, we're gonna change that to JNP so the log, updates and doesn't round. I guess that doesn't work. Okay, we're just gonna keep it as MP then. So next we are going to start doing our figure. So we're going to do fig equals, so make subplots, and we're wanting to do rows equals 1, columns equals 1, because we just want that. And then we're gonna do fig.add. We're gonna add scatter. And so we're gonna make a scatter plot. So the X we're gonna want as T, and then the Y value we're going to want as the log P that we have up here. And then we're also gonna make sure that the mode equals markers, so that'll produce dots instead of something else. And then we're gonna do that. Oops. And then we're gonna do fig dot update. And this just allows us to change the layout and everything. So layout, we're gonna make the height, let's say 500. The width, let's say 800. And then we're also going to do the x-axis title. We're gonna make T in kelvins. And we're gonna make the y-axis title be our, oh, I need quotes there. There we go. And then we're gonna make this the log of P in pascals. And so that should be good. And we're going to run that, make sure there's no errors. And there is our plot. So this looks pretty good. So it's following this curve. And so these are our data points. And what we're gonna wanna do is make the model, which is based on the Antoine equation. So we're gonna make a function, so define Antoine. And the inputs are going to be our values, A, B, and C, which is because the equation is A minus B over C plus T. So we're gonna want A, B, C. We're also gonna want T. So what we're gonna do is we just want it to return our equation. So A minus B over C plus T. That is the equation that we want. So we're gonna hit Shift Enter, it's all good. And then what we wanna do is we now want to make another function and we want to define the sum squared error. So the sum squared error is a way that we can make sure that any points that are above the line and below the line are just as bad. So we're making them equal. So we're just making sure that any point above and below have the same amount of error rather than having the below be worse. So what we're gonna do is the inputs, we're just gonna do Z, and that'll be an array of A, B, and C, so Z. And then we want the temperature, and then we also want log P. So I want to make sure that that's what I named it. Yep, log P. And then, so what we want to do is we want to make a model of our PV, our pressure, and we want to use the Antoine equation. So we're just going to do Antoine. And then what we want is we want to have this. So this is what we're putting in, and it's an array of A, B, and C. So we want to do Z0, Z1, and Z2. And then we also want to put T in there. So that's that. And then we want to have the error equal to JNP, so the JAX NP, so it doesn't have any rounding error, JNP dot sum, and we want that to be our model PV minus our log, so our model pressure minus our regular pressure that we have, and we want to make sure that, so we want to square it then, so all the above and below are equal. So we want to have that, and then we want to return the error. No, we want to return the error. Okay. So we don't have any values for A, B, and C. So we are just gonna make guesses. So we can just make up some numbers. So for A, we're just gonna say 10.0. For B, let's just say 2000. And then for C, let's just say 0. So now we have x0 or x0 equals, so we want to make an array of our A guess, our B guess, and our C guess. So that's what that is. So shift enter. C guess is not defined. Oh, I see. C guess. Okay, there we go. And then we are going to, so now we want to, we want to go up here and we want to also do from scipy dot optimize import minimize. So we want to be able to minimize the error. We want to be able to do that. So down here now we are going to do result equals, and so now we're going to minimize the sum squared error because we want to minimize the error. And then we're going to have, let's see, xo equals xo. And then our arguments are going to be t and the log of p. And then we also want to make sure that we have jag equals jax.grad. Let's see. Positional argument follows. Not sure why that is there. Do that. Okay. Okay, I'm gonna come back to that in a minute. Let me just type out the rest of this and I'll figure that out. So the rest of it, we're gonna want our T model equal to JNP dot linspace. So that makes sure that everything is there. And we want to start at T0 and we want to go to the last, which would be T-1. And let's just say we want, I don't know, 100 points in between, you know? And then after that, we want to do fig.add scatter. So we're going to make another scatter plot. And we want x to be equal to the t model, well, we just did. The y to be equal to the Antoine, and that would have z0, z1, and z2. And then we want it to also have t. And then we want the mode to be lines rather than, you know, dots. So if we run that, okay, so this is gonna have the error because of the result that we have. So I'm going to figure out the error and then I'll be right back.